Greetings and welcome to the Artifact Electronics channel. In this episode we'll be looking at an HP 16500C logic analysis system. I got this through eBay. It was sold as non-functional, but the seller had posted some pictures which showed that the screen actually lit up. And if the screen lights up, for me that's usually half the battle. It was cheap, under $50, except that the shipping almost doubled the price. But I've always been curious about the hardware logic analyzers, so this seemed like a good opportunity to get into them. It was a nice shape, but covered in stickers in front, which I cleaned off. The case has been pierced here. There's metal behind it, so nothing doesn't look like anything got damaged, but it was mishandled obviously. And the brightness knob is broken off. You can still turn it with a screwdriver, but other than that it looks good. So let's plug it up, let's turn it on and see what it's complaining about. It's trying to boot off Floppy. And what do we get on the screen? Well, it's telling us that the hard disk has failed, and also the system disk is not found because it tries to read it either off the hard disk or the floppy in front. I hadn't inserted anything in there, so it just gets stuck right here. The unit basically has a built-in BIOS that does a self-test, but the entire OS is contained on either a floppy disks or the hard disk. So this is as far as we get. I did some poking around, and thankfully on the Agilent website you can find zip files that contain all of the OS files. You simply format a bunch of disks on a PC in FAT16 format, unzip each of the OS files, and copy the resulting files into the root directory on the floppy. There's 4 or 5 floppies you get from that, but I have disk 1 here, and I'm going to put that in and see what the unit says when we try to boot off the floppy. And that's going to take a little bit, so while we do that, let's talk a bit more about this unit. The unit's basically a mainframe. It doesn't have any specific purpose cards built in. It has 5 slots in the back, and you can buy, or you could buy different cards. This one came with a couple of logic analysis cards and also an oscilloscope card. So while it's loading, these were made in the 1990s. They come with an 8.5-inch touchscreen, which is obviously a raster screen and in color. The format is which I found is, the resolution is 576 by 368, kind of non-standard. I guess you could get a converter box and put it on a bigger monitor, but if this thing's sitting on your bench, the screen, in my opinion, is big enough for you to see what's going on. Now we can see the floppy disk activity indicator over here that is trying to load stuff, and that's all taking a while. We definitely need to fix the hard drive, because I'm guessing that it will load much faster off the hard disk. If you're going to have to wait this long every time, I think that renders this unit completely useless. There were 3 revisions of this, and it's complaining about the hard disk again. but it pops up the main screen. Now, I said it, there were 3 revisions of it, the A, B, and C suffix models. The A and B are, from what I have read, not very useful in today's standards because they're extremely slow. And I think the A couldn't even support a hard disk. So if you're gonna get one of these, I would highly recommend going for the C version, which was the final version they came out with. The others weren't DOS compatible either as far as floppy formats, so anything before this is going to be difficult to use, and the prices for the C are really not that much higher than the B's and the A's. But after it came up, keep in mind that this has a BIOS built in and loads the OS entirely off the floppy or hard disk. It's telling us that there's 2 cards in here, one's unrecognized and the other one is the 1 gigasample per second oscilloscope. I think the reason it is giving us an unrecognized for the first card is because the driver for that card was not contained on the floppy. And that's probably also why it complained about the hard disk not being there, because it was looking for that driver. But it boots up, the screen is very readable, and we should probably have a look at the back and see what kind of cards we have, and then after that try to figure out what to do about the hard disk. Here's the back of the unit. I took out a few things. There are 2 blank filler panels in here, and you're supposed to insert the cards from the bottom up because of the way the lips overlap. So what I'm going to do is put in another filler panel, and next we have the oscilloscope card, which is labeled as the HP 16532A 1 gigasample per second oscilloscope, and it's a 2-channel. And next we have the HP 16551A 1 megasample analyzer, which gives us 110 megahertz state and 500 megahertz timing analysis. And we're supposed to put them in and tighten them. I mean, the results at this point aren't going to change unless I make a floppy that has all of the proper drivers on it. Unfortunately, I looked at the file names and they weren't all very descriptive about what drivers they were, so I wouldn't even know right now which files to put on the floppy. And there's only one solution, and that solution is to find out what we can do about the hard drive. Another plug-in card it came with was this logic analysis card, which is the model 16517A, 4 gigahertz timing and 1 gigahertz synchronous capability. The problem with this one, and you can see because it's higher speed, the pods actually don't just plug in, but are rather integrated into the board so as to reduce noise interference. Unfortunately, there's a problem here, and that is it looks like the wires for this pod got caught up somewhere, got pinched, and a lot of them are either cut or exposed wires, and the state is probably not very good, so I'm not even going to test that for now until I get a chance to either splice these. These are very thin wires, they're going to be somewhat difficult to splice. So maybe I'll just look around and see if one of these cards becomes available, but I think for my purposes the existing card that samples at a lower speed for logic analysis is going to be sufficient, but you never know what pops up on eBay. Let's put this aside and just quickly have a look at the rest of the back of this. Power section, degaussing button. So it has a manual degaussing button, which I find interesting. It has connectors, an RS-232 connector, a parallel printer. I guess you can do screen prints on it. PS2 compatible mouse and keyboard inputs. This one says in and out port, whatever that is. There's the LAN connector, target control, which means it'll generate vectors for you to test whatever system under test you have. And what it has here look like miniature SCSI connectors, or they could be external IDE connectors, I'm not sure. Here of course is a scope card with the 2 inputs, and over here is the logic analysis card that you have to plug in a cable like this, and then at the other end there's 2 plugs like this, and that's what you connect your cables and grabbers and everything else to, which you use to connect to the device that you're testing. There's a large fan here, and there's another large fan over here. So they're very serious about keeping the temperature low and annoying me to no end. So now let's go on and see what we can figure out about the hard drive. I've removed the top and bottom covers. What we're looking at is the bottom of the instrument and the rear over here. And what I found in here was a hard drive mounted on this plate over here with the connectors poking through from the bottom. And when turning on the system, it just sat there making clicking noises for a while and then shut down. So obviously the drive is defective. It's a Quantum Fireball, and HP Hewlett Packard labeled, and I think from reading some of the stickers it's a 540 meg drive. I did some more research on this, and it turns out that the OS accepts up to a 2 gig drive. So of course I went on the hunt and to see if I could find anything in that size, and you can, but they are incredibly expensive. I mean, by incredibly expensive, you know, $40, $50, but I consider that incredibly expensive for an old hard disk like this, which is just going to fail on you again. So the way to do this, and I've done this before on some synthesizers, is to adapt this to run off of a CompactFlash card. There are inexpensive adapters being sold on eBay, and they look something like this. You put the CF card in here, and you put the ID connector in here, and it acts just like a hard drive without any noise. Now, these boards have no smarts on them. They're basically wired through. They do have a master-slave header, that should be, they need to have that. This particular card will actually let you use 2 CF cards, but that's not interesting to me. I just need one thing. I had a bunch of these that I've used previously. So really any card should work, but I wouldn't use the cheapest of the cheapest, because they're not very expensive. I'd get something something that maybe costs more than $2 per card. Now we get to the actual CompactFlash itself, and it turns out that the devices are very sensitive to what type of card you use. Again, I had a few old ones. I went through 3 or 4 of them, and some of them were not recognized at all. Some were recognized and I was able to format them, but I wasn't able to copy to them. Then there were some that I could format and copy files to, but then it wouldn't recognize the files. So what I finally ended up using, and I found this one in my collection, is this card. It's a 2 gig card. I think I got it from a large office supply store a long time ago. And this card actually formatted. I was able to copy all of the files, the OS files that I downloaded from Agilent to it, and get the device to boot off of it. Now let's turn things around so I can show you how I physically mounted all of this inside, and then let's have the pleasure of observing it boot. So here we're looking at the top of the unit. The rear is here, of course with the cover removed, and we can see that I took this card and I drilled 2 mounting holes in the plate that used to hold the hard drive from the other side, and screwed it into that plate. The IDE connector and the power connector were right behind this going to the hard drive, so I just brought them to the other side of the plate. The IDE connector plugged right in, but I needed an adapter for the power connector, and I got that from old cables that I collect. That basically it's an adapter for floppy drives that use the smaller voltage connector, and once that's plugged in, the card itself, of course, simply slides in, and that's that. I initially tried to format this on the PC and then copy all the files over, but it wouldn't work. The machine would not, the analyzer would not recognize the card. So finally I used the built-in tools that are actually contained on the first floppy that I booted it from, and I was able to format this card and then copy the files over. The file copies were a little bit painful because I couldn't figure out how to do a copy all like an X copy. I actually had to go in and copy every file on every floppy manually. It took a little while, and I won't go through that again, but all of the files are now on that CompactFlash. And next, let's see if we can get this guy to recognize it and boot up from it. So we're put back together again, and let's see how the CompactFlash card is going to perform. So it did pass the hard disk test, and we can see the activity indicator flashing a lot faster than it did before. It's still not super fast, but we're progressing much better right now. Obviously there's no additional noise from the drive, but with the two fans running, I couldn't even hear the clicking noise the old hard drive made when I tried it before. So we should almost be there, and we are. So it booted up. It recognized both the sample, the logic analysis card, and the oscilloscope over here. Now, one thing I did find before was that the topmost slot, plug-in slot in the back, seems to be a little bit flaky, because whatever I plugged into it, I used to get intermittent unrecognized card messages in the first slot. So the connector may be wonky, or some of the solder joint on it may have cracked, but that's for another day. Right now we have two functional cards in here, and let's go ahead and test them. I'm going to test the scope first, because it's easier. I can just hook up a BNC line from the function generator and see if it works. So I've plugged the function generator into channel 1 of the scope, and what we need to do now is go in and select the scope, and what we need to do next is so coupling this instead of messing with all of this. I mean, first of all, we have to enable channel 1, and I didn't even have to do anything. It just came up. There's our sine wave, and we can change various things. It's set to 5 microseconds per division right now. So if we want to change that, let's change it to 10. Or we can go the other way and change it to 5. And I wonder, I'm going to try to use, oh yes, you can use the wheel, the data wheel on the side to change things, so you don't always have to enter everything by hand. So there's channel 1. And now I'm going to go in the back and plug the input into channel 2. The analyzer almost capsized. So it's in 2, and I noticed we were capturing here. So what I'm going to do is enable channel 2. And it's going to split the screen, but it's basically not running continuously right now. So you do have to tell it to run. And obviously the settings for channel 2 are incorrect. So we're going to use the auto scale. And there you go. Now the trace on top disappeared because there's no input to it, but I have them both enabled to demonstrate the dual channel mode. And looking at other waveforms, let's put this in run repetitive, so where it updates itself all the time. So there's a square, and there's a triangle. I don't have a T connector to put the traces on both sides right now, but as you can see, scope card's working just fine. And that was an easy and successful test. So next, let's hook up something to the logic analyzer part and see how that works. Now it's time to test the logic analyzer part. I've brought out the pod ribbon cables from the back. This they plug into the analyzer plug-in. I'm using one part of it only, and each one of these plugs supports 16 inputs and one clock input. I'm probably going to test this in timing mode without a trigger because it makes things easy. So we have the ribbon cables out here, and then we have the pods connected that have the actual input wires with grabbers at the end, and we hook those to the signals that we want to look at. Now, an easy demo would be the output of a binary counter, and the easiest way for me to do this right now is I'm going to use this Eurorack module. It's a Doepfer A160 clock divider. It has a trigger in or a clock input, a reset input, and then 6 stages of division coming out. No big mysteries for this module. If we look at it here, it has a CD 4024 7-stage binary counter chip over here, and it looks like the input is conditioned by this transistor and fed into the clock input of this thing, and then the outputs go through driver transistors and feed the jacks on the output. So let's hook this up and see what the output looks like. Should be familiar to most of you. We're simply going to see the output of a binary counter. Now this has 6 outputs only, because I don't think there was more space on the front panel. The chip is actually 7-stage, but it resets itself on the divide by 128 count, so that we see 6 active counts coming out of this. I went ahead and hooked up everything, which is one of the more tedious parts of logic analysis. The Doepfer got power and an input clock, which I initially set at 15 Hertz, so we can clearly see transitions on all of the LEDs, and yeah, it's just a binary counter, 6 stages long. Even though the chip is 7 stages long, there's not enough room on the front panel to add another jack, so it resets itself when the divide by 128 pin becomes active. Notice that I've used an IC clip to hook up all the signals here, and you could say, well, wait a minute, we want to see the outputs. Well, you really are seeing the outputs, because the only difference between the chip outputs and the front panel outputs is that they are buffered by a transistor, by a driver transistor each. So visually, the signals will look virtually identical to what's coming out of the chip. And it was much easier hooking up to this because they kept slipping off the jacks when I tried to hook them up there. But it's running here now, and let's see how to configure this guy to show it to us. So we select the acquisition board for logic analysis. We land in the configuration page where it shows us 2 analyzer boxes. And what that means is this actually contains 2 virtual analyzers that you can assign different pods to and mix and match and do all sorts of wonderful things with. For our simple app, I'm simply going to go to the pod that's showing activity and assign it to machine 1. This is a really useful feature where instead of wondering why something doesn't work or you got it hooked up wrong, you can immediately tell whether there's activity or constant voltages on any of the inputs that you're interested in. So the next thing we have to do, actually the next thing we have to do before I forget, is this low frequency is not very good for logic analysis, so I'm going to crank it up to 10K, and so here we are at 10K, which is clearly indicated by the LEDs looking on all the time, and also the little helpers here are permanently showing up down arrows, telling us that there are active transitions happening on those lines. The next thing we need to do is select the format, and what we do in the format is, first of all, we turn on which pods are active by clicking on this and turn this on, and what we can see is it's basically showing us placeholders for all 16 inputs coming off of this pod, and sorry, it's actually showing us 32 inputs for both pods and a clock each per pod. What we're going to do is, since we only have this first one assigned in the configuration, we're going to go in and just turn on the bits that we're interested in, and that's bits 6 through 0. And again, we have the convenient input monitor here, and what we've done now is that everything that shows activity is enabled. And last but not least, we go to the waveform display, and let's see, let's set the seconds per division to 500 microseconds, and no delay, a sample period of 1 microsecond, and run that, and there's our display. So it's running in repetitive mode right now, and the only thing that could be considered wrong with this is because we're running in timing mode, it's not synchronized, so it's using an internal trigger and just starts sampling at arbitrary points. The way to do this properly would be to use the divide by 128 chip output and use that as a trigger, and we would always start at everything being 0. But it really doesn't matter, because we can see the characteristic display of a binary counter coming out of here, and that shows us that this seems to be working well. Now, if we want better resolution on the later stages, we can do one of two things. We could crank up the frequency, which would narrow these pulses, or we can just go and change the horizontal resolution of the screen, and we went into the wrong menu here. Pen just doesn't work very well on the screen. So let's change this to 1 millisecond, which should narrow the top pulses and give us better resolution, and it does. So now we get the top, which is the actual input signal, and the 6 subsequent signals, which are the progressive divided outputs. So that looks exactly like what you would expect, and I think that tells us that this acquisition card and the software that we put onto the CompactFlash are working correctly. One thing I failed to mention was that if you have an X Windows machine, it supports that, and people have reported good success, especially being able to communicate with the internal hard drive or compact flash card. I did not have anything with X Windows handy, so that didn't work. I mean, there was another option, and that is there is a menu option for the LAN connection, and you can go in and set up everything. Yeah, you give it a static IP and set up a bunch of things, and supposedly you're then able to connect to it from an FTP client. I did use an FTP client from from two PCs, one with XP Pro and another one with Win7, and they were both able to connect, but I was unable to do any file transfers with it. It would just time out. The FTP command set that this recognized, it seems to be a bit ancient, because the commands getting sent out by the PCs, about 20% of them weren't getting recognized by this, and it just wasn't worth spending a whole lot of time on it, so I did it the manual way, i.e. formatting the CompactFlash card and copying everything manually. But it's up and running, and I guess the only time I have to do it again is if I get another one of these, or if the CompactFlash card fails. But as long as I have a good set of floppies for it, or even the zip files in computer readable form, I should always be able to recreate the CompactFlash hard disk. So that brings us to the end here. It's a nice unit that was probably really expensive. I didn't research how much these cost when they were new. Where does this fit on my lab bench? Frankly, it'll fit into the boat anchor section right next to the HP spectrum analyzer I have. And I don't use boat anchor as a derogatory way of describing these, but rather the boat anchor section of mine will contain instruments that are not used on a daily, weekly, or even monthly basis. But they are fully functional. They did what they were supposed to do whenever they came out, and they're still prime examples of what technology was like when they came out, especially the HP equipment. So with all that said, time to shut this guy down and let him go to sleep again. And I hope you enjoyed this, or you learned something. And if you did, don't forget to subscribe or thumbs up, and eagerly look forward to the next episode. The next episode is going to be about this module on how to replace the LEDs to different colors. No, I'm only kidding about that. I wouldn't do that to you. But I haven't chosen yet from my stack of things that need to be looked at what to do next. But if you're a subscriber, you'll be the first to know. See you later.